Here, guys. So thank you so much to be here.
No, thank you so much for organizing. I don't think we ever had ETH Tbilisi before, so Ali was a great volunteer for this effort to happen, especially with Ethereum becoming the home for privacy. And I think that's the right time to do something like this. Now we see lots of interest in privacy. And usually when we see such interest, it cascades to lots of events such as adoption of the vector. So I think the sector had lots of problems, right? It started with compliance problems before, then with usability problems because it was really hard and clunky to use privacy. And the need for privacy was always growing, such as, like the user experience, right? So now we are in this overlap when these two lines basically intersect and finally forming the need and making privacy reality. Of course, like there's always some government caveats, right? So how to make sure privacy is compliant. But I think we finally reached the right place and home for your assets on chain. All right, so Hinkal is a private home for your assets, right? And here I want to break down privacy in two different verticals, right? First is finance, right? Like one big shift, we see that finance is moving on chain, right? It's a huge industry. Lots of chains are focused on finance, like Solana's, end value proposition is internet capital markets, right? What I like in Ethereum is that it actually thinks more than finance. It thinks about, like attention, like how to prevent, governments from intruding your privacy, and it's just more global vision than just capital markets, right? So we have this, like privacy actually has these two forms, which is first is privacy prevents you from attention economy, right? So if privacy works well in the future, it will finally kill attention economy, so no one can sell your data. Google, Facebook, and other big platforms won't be able to own your data, so you won't become victim, and you finally will control your attention at scale. And the other one is your digital finance, your assets. So today we'll focus on this, and hopefully in 5 years we'll speak about Cypherpunk and this attention economy killer as privacy on chain. So what we see now is that traditional finance is becoming obsolete, right? So the biggest companies such as Stripe and Alibaba are launching their own chains. And what it implies is that like Visa, MasterCard, networks, banks globally are becoming obsolete with their systems. We have lots of branches in banks, lots of people working there. So I don't expect that they will actually adjust to like crypto generally. So my expectation is that fintech will actually kill lots of banks if they're allowed to do it with the governments, right? But this is unavoidable because banks won't be able to adjust, so ultimately new entities will be created, and these entities will have licenses, and these licenses will enable them to create crypto banks, right? And we see this with Aribor in the US now, with Palmer Luckey and Peter Thiel, and lots of other efforts such as Stripe, right? I'm sure that Stripe, Tether will also acquire banking licenses and they will become banks, right? And in this world, when banks move to chains and new entities are created to completely replace traditional financial rails, one of the biggest problems that still is happening there is privacy, right? So whenever you move your assets on chain, you can immediately see how much you have, how much your friend has, and everyone else, right? Especially when it's happening with peer-to-peer transactions. When you know your counterparty, this creates one of the biggest problems because now it's not just pseudonymous addresses, it's just your friend and you know all the history of transactions and what they have as well. In the US, we have two regulatory clarity now acts. It's Genius Act and Stablecoin Act. Stablecoin Act was already passed, and now it's about Genius Act to get full permission to basically enable everyone to launch stablecoins and to move assets on chain. So with this bottleneck, there are three ways you can solve for privacy, right? So first is, which is quite popular now, is a chain level privacy. The problem with chain level privacy is that you sacrifice scalability and you sacrifice lots of UX primitives such as public AMM pools and others, right? So basically you end up launching very slow chain, and that's a big sacrifice in my opinion. Plus you don't have any network effects, right? So to bootstrap layer 1 chain, it's incredibly hard, right? Who was able to do it? Probably 3 chains ever. The rest of the chains are called ghost chains. So no one wants to become ghost chain. Second approach to privacy that was quite popular before with Tornado Cash was up layer privacy. And it implies that you sacrifice capital efficiency of your liquidity and user experience. So your assets are stale on chain, so they are not active, you cannot do anything. And then you have to do lots of clicks to access this user experience. And we had this before, so our first product was actually the DApp. And we had 250 million volumes for the DApp, but then we realized that this is not scalable approach. So the most scalable approach for privacy is wallet level privacy on public chains. So with all the advancements of technologies such as ZK, stealth addresses, TEs, as well as FHE, it became possible now that you can actually almost don't feel privacy while accessing any type of transaction on public chains such as Ethereum and Solana. So Hinkal is a gateway for fully self-sovereign and private money. You can move on-chain directly to Hinkal private address, and your assets are sitting in the shielded pool with UTXOs, and you have your own private address inside Hinkal. It implies that you can make any transaction in full privacy. You can pay your friends in full privacy. You can do yield farming or trading in a full privacy. Proof generation is client-side proving, so it's fully secure, but you have the choice to do proving in TE, right? And this way, on weaker machines such as your phones, you'll be able to generate zero-knowledge proof and make the transaction instant, right? That's how we solve the problem of instant transactions, right? That usually ZK has. What appears on-chain for all transactions is Hinkal smart contract. And basically, like, you can have sender, recipient both having Hinkal addresses, and what appear for this type of transactions is sender Hinkal, and then recipient is also Hinkal smart contract. So this way we avoid any traceability of your money on chain. And think about also like current big trend, which is crypto cards. So crypto cards are going to actually take the world, because you can earn way more money with crypto accounts. I have 10% APY on my current account, 3% cashback with EtherFi card. But the problem is whenever you send money, you have to KYC there, and then you basically show your face and link your ID with the history of your transactions, right? That's one of the biggest problems that Hinkal also solves, right? So we're partnering with EtherFi there, so you can send any asset, USDC, ETH, to EtherFi without revealing the history of your transactions, and spend your money without any traceability with a proper hygiene. So the product suite that we have is first, the most important one is Hinkal Wallet, right? It's a fully consumer wallet. It applies to traders, applies to people who want to own money privately, who have shitty governments as well, and don't want governments to have any exposure on their activities, right? And then just basic consumers who want to pay in crypto. Second product that we are developing right now is Hinkal Multisig. And this mostly for institutions, organizations, so you can connect with your multisig or MPC accounts, such as Fireblocks and others, and then you basically activate Hinkal transactions with their signatures. This allows us to access kind of like bigger audience in terms of TVO, because most of money in crypto it's actually in the hands of few bigger whales. And the last one is Hinkal for developers, right? So the problem, we actually started with developer suite, so SDKs and APIs for payment networks. But the problem is that if people don't understand privacy or ZK, right, they won't be integrating your API and SDK. That's actually what triggered our decision to build Hinkal Wallet. So with Hinkal Wallet, we can actually show everyone how easy it is to access privacy and how huge is the problem. So this is our next step, where we released Hinkal Wallet. It's fully public, everyone can use. So now we can actually introduce SDK for developers, so any payment network or payment solution can integrate privacy within their system. Now we are getting to the heavy brain part, so prepare your like my co-founder, brother, and CTO Nika will introduce.
Hi everyone, we will go through technical details of our protocol. My goal here is to explain you how we build Hinkal, at least give you some recipe how to build it. As Andrei Karpatis says, you do not understand something unless you build it. And this is my approach for you to understand something in our presentation from technical perspective. So when we build Hinkal, essentially we build information system which is based on some primitives. In our case, it's cryptographic primitives, because cryptography is used for privacy, anonymity, to achieve compliance when we use cryptography. So I will explain some basic functions by some basic primitives that we use in our protocol. If you think about Ethereum signing, Ethereum encryption or hashing, Ethereum uses some different kind of primitives, like maybe if you think about KCHAC or SHA-256, it's a common hashing algorithm on Ethereum, and ECDSA signature for signing transactions on Ethereum. So this is very common standard cryptographic primitives used not only on Ethereum, but generally everywhere in the industry. But when it comes to ZK, it's not the same essentially, because ZK uses a little bit different math in addition to normal computation, and it doesn't like some kind of operations. For example, it doesn't like if conditions, somehow it doesn't like. And common primitives that is used generally in the industry, such as KCHAC, are not applicable for ZK because they are computationally heavy, because you need to prove something in ZK to the chain, and chain should verify you. So that's the reason we picked some non-standard primitives. And if we're talking about elliptic curves, it's baby jab curve. It's baby because it's a little bit reduced security of the system, but allows you to prove efficiently statements in the ZK. Here I give a description of the curve. I will not go to every detail, but I will cover the high part. Second one is Poseidon hash function, allowing you to prove in ZK some hashing statements. For example, that off-chain UTXOs generate this commitment. You prove in ZK by showing that this UTXO gives you the specific hash. And for generally for ZK, we are using Groth16. Groth16 is the golden standard in ZK. It's one protocol that was introduced in 2016 by Jens Groth, and still even now it's not beaten in all parameters. So it's kind of gold standard that many protocols use up to now. We are using it, and for Groth 16, it's implemented in Circum. So Circum, it's a library that allows you to generate provers, where you prove off-chain some statements. And also Circum allows to generate you verifiers. These are smart contracts that you deploy on-chain, and you verify statements. I will talk about what kind of statements you verified in the next slides. First of all, if you think about privacy, you generally cannot consider only blockchain as information system. You need to move step up. You need to consider users who are using this blockchain, because we are talking about privacy of transactions of these users, right? So they are off the system, off the blockchain. So we should consider a little bit bigger system in this case. And the key, the recipe here is that you should have some kind of information, some piece of information that is only known by you, and it should be stored off-chain. In our case, it is stored in our wallet, and it's a shielded key. We call it shielded key. It's an additional set of keys that is stored off-chain. Nobody sees except you, and with this shielded key, you are allowed to do shielded transactions that I will explain later on. Just 1 second. This shielded key is split essentially into viewing keys. Go back. Viewing keys and spending keys. Spending keys allow you to spend funds that belongs to you, shielded funds that belongs to you, and viewing key allow you to essentially view all the funds that you have. You may ask why we separate it. In Ethereum, it's not separated, it's the same, but Ethereum is a public network. Here, when we think about privacy, we should be able to differentiate ability to spend something privately and ability to show others these funds. For example, you want to prove the government that you don't own more than $10,000 in shielded assets. You can do it with just giving viewing key. So when you give viewing key, you don't give access to the funds, but essentially you give access to view the assets. So that's an important distinction that allows you to differentiate these two functions. Let's talk about stealth addresses. Stealth addresses is not a completely new primitive. Essentially, they originate from Diffie-Hellman asymmetric cryptography. It's a generalization of the cryptography. I will remind you, for Diffie-Hellman, we have one private key and one corresponding public key. Stealth addresses is generation of Diffie-Hellman algorithm protocol, when for one private key you have multiple public key. So if you look on the left, this is a canonical public key. It's just one point on elliptic curve. But for stealth addresses, you can generate H0 and H1. This is second public key. So you can generate any number of this public key, any finite number within the field. And this allows you to achieve privacy when the outcome of the transaction is uncertain. Think about when you want to swap one token for another token. You never know what will be the outcome exactly, because there may be some blocks before you, the transaction within the block before you that may change the prices, and your outcome may be different. Stealth addresses allow you to capture this uncertainty in the outcome, such that users who submit this transaction remains private. Very important concept here. Who is familiar with Zcash, the protocol? Okay, good. So Zcash was one of the original pioneer in privacy, and it introduced this system called UTXO system. It's unspent transactions. And this term essentially comes from the Bitcoin. Like every node, every amount is UTXO, and when you spend it, it's nullified. So this is something familiar to you, this UTXO system. And it comes out that this UTXO system is really important for privacy. It allows you to essentially store your funds and then claim the ownership of these funds later in ZK without revealing who you really are. Think about UTXO as nodes, And on each node, there is the owner of this node. For example, 5 USDC node belonging to Georgi. But nobody knows that it belongs to Georgi. What Georgi can do, he can prove in ZK that he has a private key that generates public key, which is inside this node. Once he proves this statement to the smart contract releases this 5 USDC and tells Georgi, you can spend this 5 USDC however you want, essentially. When this 5 USDC is released, you can essentially call any protocol, Uniswap in our case, and swap this 5 USDC to 5 USDT. But when you want to deposit back this 5 USDT to the shielded pool, so you don't link your identity, here when stealth addresses come to the play, you provide stealth addresses. So this is a one-time address which doesn't reveal your identity. The beauty of stealth addresses is that you can generate billions of stealth addresses and all of them will be unlinkable for the outsider. So the same person can do any type of transaction and all these transactions for the outsider will be unlinkable with each other. That's the beauty of this Diffie-Hellman extension. And the last part, this is a that's not new part, but somehow we should account for all the balances in the system, UTXOs. And the common way is to do it with Merkle trees. So essentially, we should know the state of the system. It's the balances of all people in a smart contract and what is essentially actions they are doing. And we need to capture it with just one number. And this number, if you think about cryptography, is generally hash of some data. Data can be arbitrarily long, but you still can hash it and prove integrity of this data later. You may ask me, like, why don't you use generally one hash function and essentially hash all the data? But the problem is that when you do transactions, you remove and add UTXOs to the system, and you need to do it efficiently. Because if you rehash everything, you need whole previous data, which is really inefficient. What you need to do is to do it in a very short time. And if you have n data, n number of data, the shortest way is to do it is in log n operations, and Merkle tree allow you to do this. So by insertion, if Merkle consists of, let's say, 16, you can do in 4 operations. So quite fast, efficient way to prove integrity of your data and to record integrity of your data. We have 2 types of Merkle trees. I want to stress it out. So if we think about Merkle trees, the main questions that we have, do we need to hold the whole Merkle tree or we can hold just one part of Merkle tree? And the answer to this question depends what do you want to achieve. If you want only appendable Merkle tree, when you only can add some leaves, then the answer is that you can essentially store log n elements, is the most right leaves for every level, and then update these components for every insertion. Insertion just adds another additional leaf to the Merkle tree. And the second point is about the case when you want to remove Merkle tree component. Think about the user who essentially deposited some asset in the Hinkal, but later somehow we find out that this user is a hacker, stole the funds, and wants essentially send these funds to centralized exchange. In this case, system should be able to heal itself and to block the access of this hacker to the funds that he stole. Well, how can we do this? We can do this with removable Merkle tree. So we should remove the access token, the leaf of the hacker from the Merkle tree. But to do this, just the right leaves, right elements are not enough. You need to have the whole Merkle tree. And by removing just one component, you need to update the upper hash of the Merkle tree. So that's a distinction between incremental Merkle tree and full Merkle tree. So in case of access tokens, for access-gated Hinkal, we use full Merkle tree, and for commitments and UTXOs, we just keep incremental Merkle tree.
things to remember for non-technical people, based on what Nika said, is baby jab jab, zk, status addresses at Berkel trees. And now we can move to compliance and security. So we started actually Hinkal right after Tornado Cash sanctions. And one of the biggest problems we had is to persuade law firms and to make a legal memorandum that we actually can have compliance with privacy. Right? It was quite tough to do, but ultimately the system that we built around privacy is fully compliant with governments, so we never try to avoid any governments or do something against them. And at the same time, it protects people, right? So we don't have any special keys that allows to reveal transactions, right? So it's a full privacy of your data. And the way we achieve this is twofold. So first is when people interact with the wallet, we actually check if the wallet, that they're depositing from is compliant. And for this, we run the compliance check with chain analysis, right? So if it is red flagged wallet, it's actually not allowed to interact with smart contracts, so the transaction is reverted, right? So that's a first kind of checkbox to make sure that we are not allowing illicit wallets to interact with our core smart contract and core privacy primitive. And then if and this is an entry point, right? What happens after the entry? So for example, you were not red flagged, suddenly you became red flagged, right? And you're the inside Hinkal. And for this type of use case, we actually allow users to revert transactions. So basically to lose privacy and to send back only to the main address he deposited this asset from, right? So this allows us to prevent the user from actually using privacy primitives with us, and at the same time, making sure that he is getting the asset back if if he has nothing to do against the law, right? So lots of actually chain analytics tools just misinterpret the data, and so they can red flag you because like the centralized exchange that you're depositing from got some contamination from some other illicit users, right? So you should not be reliable for and in charge for someone else's mistakes, right? And the second primitive that we run for large deposits is this kind of primitive that is called reusable attestations, right? So reusable attestations is basically allowing you to prove that you did KYC somewhere before, sometime before, somewhere in internet, such as, it can be Bank of Georgia, it can be, Revolut for Europe, or Venmo account for the US, right? So what you do is you generate zero knowledge proof of ownership of your account, and then we accept this proof, but you don't share any data with us. So it's a fully private way to prove that you actually have information, you actually did KYC sometime before without revealing this to us. In addition to this, we have a bunch of other soul-bound tokens from Binance, Galaxy, ZK. If you did KYC with them, you are immediately whitelisted, so you can access the protocol with any deposit. So this rule triggers actually for deposits over 1K of each asset. So if you have 10K of different assets, you don't have to KYC or provide any reusable attestation to us. Yeah, we have a team of 18 people actually now. My background, I started as a professional wrestler. I was wrestling Sambo for 10 years. I was twice world vice champion actually in Sambo. Then I spent 5 years in investment banking, went to Stanford, did 2 degrees, MBA and master's there. And during my second degree, actually, we started Hinkal. I'm also the founder of Silicon Valley Icons. It's the biggest Stanford founder community. Nika has CTO, he's PhD from University of Warwick, and also built few apps. We built few apps before, actually, both in blockchains and Web 2. We are always hiring, so we have everything for great people to join. So we are entry point to blockchains, right, to the new home for finance. There is also the vision beyond finance, where Hinkal is also entry point, right, where that kills attention economy and allows public blockchains, right, to be the new ledgers for this economy with the ownership of, your assets. We have all the great technologies, so onboarding is a bit longer for non-technical people because it's pretty complicated tech, right, and you have to understand it, but it's possible. And then we pay great salaries, every 6 months promotion and bonuses. We raised over 6 million in seed round. We are planning to raise Series A soon. And yes, own your money with Hinkal, hinkal.pro. Here's my Telegram and email. Feel free to reach out if you have any questions.